Okay, so you have any questions from yesterday's session? So yesterday we spoke a lot about, I mean, the basics of AWR report, how to analyze the AWR report. Now we'll start with how to read and how to analyze and what are the different sections that we need to look at in the AWR report. Okay. Yesterday, as I told you, it is very, very difficult to look at all the different points. Okay. So as we are only talking about performance standpoint of view, by reading the AWR report, we are trying to understand uh, easily to solve all the database slowness, or if you have some any of the high weight events, or if you have any of the contention types which are causing high degradation with respect to the response times, or if you have long running queries, I mean the slow queries and many more. Okay, so to understand all the different issues, you take some AWR report, you read that report, you look at some important points to see what how the values are behaving, and accordingly you write a recommendation or a suggestion saying that this is what happening inside the database at a particular period of time, right? So can any one of you confirm whether you are able to see my screen or not?
Not yet. Okay, we have when can we decide like we have to go for this AWR uh, report?
See, this is you. I mean, you have to take an AWR for all the database slowness. If you feel if you have monitored or if you have observed something like the database is slow,
Yeah,
okay, or if you
that we
see
can
some
see it
high
in
response
the
time,
APM tool, right?
you can see it. So
Okay,
there is one important document actually that I have to share it with you all, but I did not get the document. I shared it with previous batch. There is a
okay,
document called Monitor's Guide. Okay,
okay.
the counters and monitors guide.
Yeah,
What that guide will tell you is what is Oracle, why you should monitor Oracle database, all the
okay,
monitors and counters that we have inside the Oracle, each and every metric is explained from the basic to the advanced concept.
okay.
So before you start any of the engineering on any of the server, right,
Yeah,
you must be knowing all the four whys: what, when, why, and how. I mean, 4W theory was there, right? So
yeah.
before you take this AWR report, you need to understand all the different metrics that you have on Oracle and how you can configure Oracle, and when you have to take this AWR report. So AWR report is a very common practice if you are doing any of the load testing, especially for Oracle. Like AWR, you have similar reports for other databases like Postgres or MySQL or Cassandra. The other databases that we have similar reports where it can tell the performance statistics of the database when the load test happened.
Okay.
Okay, so you able to see my screen?
Not yet. Yeah, we can see now.
No.
Yeah.
See, there are multiple sections. If you talk, there are so many sections. Uh, okay. Yesterday we were talking about when to take the multiple reports, right? For example, yeah. For your question, when we have to take Oracle AWR report, we have to take the Oracle AWR report anytime you see some issues in the some slowness in the database side. So how do you identify all the slowness in the database? Okay, any of the transaction which is having very high response time, okay, so it means that your database is giving some problem. So it is a direct saying like your database is struggling to fetch that data. It is getting the retrieved output for the request that has been sent from the user side, but it is taking more time to give the appropriate response. So when you are testing your application with multiple users, when you have some simultaneous users with high concurrency, with high user rate, with high number of requests and connections and hits, so your database will be obviously slow at some point of time. So in such scenarios, you take something called AWR along with ADDM. So if you remember yesterday's class, we are only worried about three different reports that we have. Okay. So one is AWR, one is ADDM, Automatic Database Diagnostics Monitor, and one is ASH, Active Session History. These are the only three different reports that we take. Can all of you mute your lines, please? Thank you. So this is a very lengthy report, but you need to analyze you need to analyze and read some relevant information that is required only to troubleshoot the issues and to quickly identify the performance degradations. That is what we do from the performance testing side. Yesterday, if you still remember, explaining all the sections of AWR is not at all possible. So we'll be talking about some of the important sections that will help performance engineer to report all the slowness or any of the performance bottlenecks. That is the only thing that you can do. Even the one who is having some 15 to 20 years of experience in the Oracle database administration, he will have a very tough time to identify, to go through all the report, to look at all the different metrics in all the sections. He cannot directly give a conclusion on this is what has happened because of this particular metric. So we cannot tell that. So we have some important sections where we talk about that. And so if database is having one performance issue, okay, so then immediately the immediate next step is you need to take an AWR report, and you need AWR report to look at what happened. So in case if you have a particular query that is not performing well, then you need to look at the execution plan of that query. How many of you know what is the execution plan? Anyone have an idea on what is execution plan?
Execution plan is like how that query is executed in a step-by-step fashion. It will give like a pictorial representation to understand, like when we write a complex query,
Hmm.
how it got executed, like what are all the steps being performed internally for that query.
Right. Actually, the execution plan will have a sequence of steps to access the data in uh, the query that we have written. Okay. So in the RDBMS, if you want to run a query or if you want to execute a query, there is some sequence of steps according to the instructions that we have from the execution plan. The query gets executed. So if you have any of the steps, I mean, if the execution plan is not given as per the standards, or the sequence of steps is not properly ordered, so what will happen is the query will take a very long time to get executed, and obviously it will not perform well. So when for the very first time when you have a query, a long running query, so you have to look at something called execution plan of that query, and there are few statistics of that underlying table. You need to look at all of them. So you cannot do, being a performance engineer, you'll not be able to understand all that stuff going back to the execution plan and looking at all the different statistics of that underlying table or some table space. You need some additional knowledge or good hands-on experience from the Oracle database administration side. So as we cannot see or as we cannot understand all of them overnight, so we are looking at something called AWR. That is the only solution. So if you see anything, any issue, AWR at least will make everyone to understand at a very high level, like what happened, how is it, what is happening exactly with this metric. So even if you remember yesterday when we spoke about this AWR, it is always a good practice to collect multiple AWRs. We are not collecting one single AWR for the entire test duration. If your test duration is for 6 hours, we are taking manually AWR for every 1 hour, right? It is always good to have two different AWR reports, one for the good time and one for the mean time, and one after the completion of your test. Before the completion of your test, mean time is the complete steady state, you can say. And the last one is after completion of the test you can take, if it is 3 hours test or 2 hours test. So every time a database is not performing well or the performance is poor, you can easily take some multiple AWR reports. If it is a 1 hour test, you can take AWR report for every 15 minutes, or you can have two different reports every 30 minutes, and you compare both of them to see what happened, right? So if it is a very bad report, to find out the problem, the only way to address all of them or to understand them in detail, you need to definitely involve the DBA and you need to have a call with him by showing all the metrics from. If you have lot of change in numbers in the report with every section, you need to take the help of the DBA to understand what happened again. You yourself as a performance engineer will not be able to understand all the sections, and if something is going high, something is coming down, so to understand all of them you need one DBA, so and he can fix all of the issues. Yes, please. So, and when you run a load test, right, you need to, while taking this AWR report, you need to stick to a particular time. So the first point is always like database is performing slow. So to resolve all these performance issues, you have to identify a specific time, like when when the database was slow. For example, yesterday at 1 p.m. it was slow. It was slow till 4 p.m. in the evening, and it seems to be normal after 4 p.m. So here what you have to do is either it can be a DBA or a performance engineer. You need to get the report for all the 3 hours when the database is slow. Right? You identified the database was slow yesterday from 1 p.m. to 4 p.m. So obviously you are sticking to that particular time and you are trying to take the initial report of AWR for yesterday 3 hours. Right? Either you or the DBA will take AWR report. That is why you are sticking to a particular time. And if you have very large AWR reports, okay, which are capturing many of the performance statistics with so many sections, okay, as I told you, instead of having one report for a very long time, uh, I mean, for example, if you take 4 hours test duration, it is always better to have some multiple reports. You can take if the performance of the database is very poor, you can also take, if you're running a test for 4 hours, you can also take AWR report for every 30 minutes. That can also be done. It is not that you have to take one single AWR report for 1 hour. If your database performance is really bad, okay, and if you're getting so many metrics, if you're having a very large AWR report, the only option that we have is we can split the large AWR report into smaller reports. So to quickly identify the issue, you have to take multiple AWRs for a very shorter time. for a very short duration of time, so that you will understand the issues very easily. So in case of rack, yesterday I told you rack. What is rack? What is rack? Can anyone of you tell me?
Real application cluster
Yeah.
that gives the scalability aspect to the cluster of DB instances.
So when you have a rack environment, right? So you will have many instances with respect to every rack that we have. You'll have a distributed, very big distributed environment. You'll have so many clusters with other instances. If you want to generate an AWS report in case of rack environment, you need to generate one report for for each instance. So you will have, in case of rack environment, you will have multiple instances. So for every each instance, you need to take a different AWS report. So it is different for every instance. It is not the same thing for every database server. So for every each instance, you need to generate one single AWS report. Okay. So since AWS report is a very huge report, you need to look at different sections depending upon problem to problem. Okay, it is not that one section will give you the section. So we have some common areas for performance engineers, and again for DBS, he can look at all the different sections, and he can give us a clear picture of the performance issues that we have inside the database. Yeah. So the first thing is, as I told you, the first section is this one. The workload repository is the first section. So in this section is you will have the database name, the database ID, the instance ID, the instance number, and the startup time. Okay, you will always have this release version of the Oracle, and it will also tell you whether it is a rack based environment or not. It says that if it is rack enabled, you can see a value called S. The host name is nothing but the name of the server on which your Oracle database is installed, and it is the platform is on which flavor of the operating system the platform is installed. It can be on, most of the times it can be on any of the flavor of the Linux. It can be CentOS, Ubuntu, or Red Hat, or it can also sit on Unix or Solaris, any of the Unix flavor. And very rarely it sits on Windows, hardly 10%. Only just because of the security reasons and other reasons. Uh, Not less than or more than 10% people will install this Oracle database server on Linux flavors. Okay. So, and you can also see the configuration of the database that you have installed. If you look at the configuration here, it clearly tells you the number of CPUs, cores, sockets, and memory that is available on the Oracle database server. And yesterday, if you remember, I told you, right, how to take an AWR. AWR is that simple. You need to go to Oracle home directory. You have an AWR report.sql scripts. Once you run it, it will ask you for how many number of days you want to take the test. You can give 1 to 7 any days, and it will ask you the type of report that you want to generate. It can be HTML, active HTML, or anything. You always choose to use HTML because the report that it got generated with .html format can be opened with any of the browser. Okay, and there is something called begin snap ID and end snap ID. Begin snap is the time that for every time, for 8 o'clock you have one snap ID. For 9 o'clock, you have one snap ID. For 10 o'clock, you have one snap ID. And all these snap IDs are internally generated from the within the Oracle database. So if you want to run it, if you want to generate a report from 9 o'clock to 12 o'clock, as per the screenshot that I'm showing it to you here. So the snapshot at 9 o'clock, the snap ID is 610, and for 12 o'clock it is 625. When you give the start and end snap, it will capture all the performance statistics related to database server, like system and session statistics, okay, segment usage statistics, resource intensive sequels that are taking long time by different cases and classes, and time model statistics and buffer cache details. These are the most important things, okay. So and it will also show you the number of sessions for each snap ID and instances and curses. So this particular section contains all the information about the database and the environment, along with the configurations, the snap IDs, and all other stuff. And I'll tell you these metrics, what are they and how they can be used. Now, if you look at the second section, the second section is, let me open another one. Okay. Oh.
Hey,
You able to
RK.
see my screen?
Yeah, RK.
Yes, please.
Hey, if you are generating AWR reports from the database, do you need to know the schema like you did with?
It will be good if you know the schema changes and the total schema, what schema you have in your database. But again, it needs a lot of other technical knowledge from the database side to understand the schema. It's not really that easy to understand the schema. But again, if you have some experience or if you have some good knowledge on Oracle database concepts, it will be easy for you to understand the schema. And if you want to, if you are the only performance engineer who is taking care of all the performance, Oracle database performance tuning, yes, you need to definitely understand the schema design.
Just like you do when you want to query the database, right?
Yep.
Okay. Thank you.
So basically, sorry. This is the latest report actually. The earlier one which I'm trying to show you is a different one. This is the older version. That is why the reason you are getting all the information here in the first section. This is the latest version. If you look here, it is giving an individual. See, first is the database details as you get, and the second one is source configuration, and the third one is snapshot detail. So, in the snapshot detail, you have the begin snap and end snap, and you also have elapsed time, and now you have DB time. Now, you are seeing the third section, right? Snapshot detail, elapsed time. You are seeing 60 minutes. I mean, there is no value there. DB time is 621, 627 minutes something. Elapsed time is 60 minutes. Can anyone of you tell me what is elapsed? I'll tell you one simple answer here. Elapsed time and DB time. in the begin snap time and end snap time. Okay, elapsed time is the total time of the duration that you have captured the performance statistics of a particular period of time. Let's say that 10 o'clock to 11 o'clock, when you're taking an AWR using start snap and end snap, the difference time between start snap ID and end snap ID is nothing but the elapsed time. Got it? Now, can anyone of you tell me what is DB time?
DB time is the total time taken by all the DB CPUs to process that entire queries and tasks.
So DB time basically is the total time or the total time that is spent on all the sessions in the database, okay, to make everything to work. So when you take the elapsed time and DB time, how do you understand the bottleneck here?
The DB time is higher than the elapsed time in this report.
If the DB time is higher than the elapsed time, then it is a direct indication of a bottleneck. Okay. If the DB time is less than elapsed time, it can be concluded that the bottleneck is not there in the database. Okay, but again, some further analysis is required to analyze the database performance bottleneck. But from this section, when the DB time is less than elapsed time, it can be concluded that you don't have any bottleneck from this section. Okay? If your DB time is very large, when you compare it to elapsed time, it is not at all a concern actually. But you have to, when you have taken the report of that particular time, if you see any performance problems, you have to go back and look at the other sections to analyze more in detail. I mean, what are other indicators are behaving abnormally and what kind of bottlenecks you have is you need to analyze from the other sections again. So the third thing is this is one of the from a performance testing time, the first thing is elapsed time, and you need to look at top 5 timed events, and you need to look at the SQL statistics and time model statistics. I'll tell you each of them. So, so the immediate section that you see is this is one of the most important section. Okay, load profile. By looking at the load profile, you will understand so many things from here. Here, if you look at the DB time, if you look at the DB CPU, redo size, block changes, physical reads, physical writes, user calls, parses, hard parses, WAMB processed. I'll tell you what are all the different metrics that you need to look from here. Now, tell me what you can understand, because load profile is one of the very important areas to look at from the performance standpoint, because we can define maybe the 50% that actually occur from load profile.
Your voice is fading.
Okay, so is it better now? I'm sorry.
Yeah.
Okay, if you look at the load profile, we can easily tell from this section, we can easily tell that maybe 50% of the bottlenecks we can identify from this section, from the performance testing side. And this section actually tells us what was the load that was there inside the database between two snap IDs. Okay, when you give the starting snap ID and end snap ID, right? with respect to load that has happened inside the database, the entire performance statistics with respect to load are captured in this section. Okay. So what do you understand by DB time here? Anyone? What is the DB time?
Yeah, to DB time is the time spent by the database to process all the sessions.
Right. Like basically, DB time is the time in Oracle spent performing all the user calls, sessions, anything. Mostly it is on the user calls. Amount of time that was spent inside the Oracle DB for Oracle to work on all the user calls is nothing but DB time. Okay. If you're working in any of the test database, you won't get the right data, but you will see the dummy data when I show it to you again on the Oracle installation part. When I use some simulators, right, you can see some dummy data. And this load profile section, right, this will give you the entire sense like how your database server will work. Okay, under load. The main point is how your database is working under load is the important point. And now tell me, what is DB CPU?
It's based on the number of cores inside the each CPU of the database server.
Basically, DB CPU is the amount of time spent on user calls, same as DB time, but it does not include any of the background process. The value is in microseconds. DB time or the DB CPU should be increased. Can all of you place your calls on mute, because I'm hearing a lot of disturbance. So you should not see any of the high values in DB time and DB CPU. If you see any of the high values in DB time and DB CPU, you need to have some further analysis, and you need to check for what reason you are having high CPU, high DB time and high DB CPU values. It's like some.
Okay,
Yes, sir.
what should be the ideal value for this? Is
It
there
depends.
any?
It depends on problem to problem, because for all the different types of load that is being generated on the Oracle database, it is not a fixed value.
Okay.
Yeah, because if it varies, right? You may test with
Okay.
4,000 users, and I may test with 80,000 users on a rack environment. So even if it is a fully automated server, I don't think so it will be the same 10.5 seconds for 50,000 users and 80,000 users. Okay, you will see some different numbers, but it is it should be very less as much as possible. Okay.
Okay.
So DB CPU is again the same that we use for and
yeah.
I am not concluding anything here. DB time and DB CPU, it can be a bottleneck. I am not concluding here. And these are the two important counters that you need to look in this section. And there is something called reader size. Anyone knows what is reader size? You see, the reader is very high. This is the highest value. There will be a huge reader generation in bytes between the two snap IDs. If you can see the per second and per transaction, the reader is generation at with a very high numbers, right?
Yeah.
So if any of the values that are very less with respect to reader size, then it is like you must be having some issue with reader. Okay, there must be some bottleneck. So for any of the performance things for the reader size, right, you have to look at the reader generation is very less, then it is directly a performance issue. So per second the value should be very high for the reader size. If the per second and per transaction, if it is very, if you notice that you have very close values, some 295 327, and you have some 495 and 326, then it must be a bottleneck with reader size. Okay? And I told you regarding one document, right? For all these metrics, some basics on Oracle, I have a document which I can share it with you all. Before you look at any of the AWR report, you go through that document first. There are few basics on what is reader size, and what is the read, and what is the write, and what is the block change. You will understand from there. Okay. So if you look at the physical reads and physical writes, it should be always high. I mean, uh, these continuously do some IO operations, right? Some physical writes, physical reads, and they're automatically performed. And always you have to, what you have to notice here is the reads are always greater than writes. Okay. So if you see more number of reads than writes, then again, I'm not concluding anything here, but a simple shortcut would be uh, this is physical reads, which is also called blocks. Is another important thing to look at. This will tell us like, the number of blocks instead causing the IO operation. To happen this IO operation, there are few blocks that will be requested through physical reads metric. So basically, this physical reads, in simple words, it will define the number of IO that happened. In this report, the physical reads is yeah, it's okay. It's I mean 122 145, and always the physical reads are greater than physical writes, right? Yeah, physical reads are greater than physical writes, and there is no fixed numbers like you need to have this many reads or this many writes. So that is why the reason I am not concluding anything here. But again, what I can do for you is there is one report that I have from my side. I'll try to delete the logo of that recent report, and I will explain you all the issues tomorrow. Okay, from the AWR report that I have. What the DBA has given some recommendations with respect to all these metrics, the high physical reads, high physical writes. I will tell you all the bottlenecks and also how to fix them from performance testing side. Okay. So user calls is another important metric. This should not be very less. The reason is because user calls is nothing but the number of user queries that are generated. Okay? You will have basically when you run the test, you will have more number of queries that has to be executed, that has to get executed, right? So
Okay, we are unable to hear you.
one minute, please. 1 minute. Allow me a minute. Okay, after user calls, there is something called parses, right? Parses includes the total number of all passes. Okay, it can be both the hard and soft parses. So I'll tell you what is hard parse and what is soft parse later point of time. So okay, so hard parse is basically these parts to tell you. I mean, these hard parts will consume both latches and shared pool area. There is a memory area called the shared pool area in Oracle database. Basically, these hard parts, right, before executing the any of the SQL statement, so it will consume both latches and shared pool area. When it comes to soft parsers, right, it soft parse basically it will reuse a previous hard parse. It means that whichever the parse that has already consumed both latches and shade pool area, it is using soft parse is using reusing the same hard parse again. So when this soft parse is using a hard parse, I mean when it is reusing a hard parse, it will consume very fewer resources. So before talking about that concept, there is one simple diagram on how the SQL will process. Okay, I'll show you the diagram. After showing that diagram with you all, then I can explain you this hard and soft parts. Okay, so what exactly are they? So I'll show you when I showed you this. When I show you this processing. So basically, there is something called wait, right? Before going to this hard pass and soft pass, we'll talk about wait. Where can the wait happen? For example, you have a client application, then you have a network, then you have a web load balancer, firewall load balancer, web server, app server. You forget about web server, app server, firewall load balancer. Now you have a database. In the database, where can a wait happen?
When the query gets executed, it has to pull lot of
Resources, right?
resources. Yes.
The wait can happen from the network or it can happen from the database. When we say that it can happen from the database, it can happen from the CPU, can happen from the disk, or it can happen from the memory also. No, I mean it. Most of the times it will not happen from the memory. It will happen either from the CPU or from the network or from the disk. Okay, so that is why the reason they are called critical resources. The resources such as CPUs, memory, I/O capacity, and network bandwidth are the key indicators to reduce the service time of any of the SQL query. Okay, and I'll tell you one simple logic. So the database is very slow. It is not able to accommodate. It is giving very high response times to run all the queries, to process all the queries. It is taking too much of time. It is taking high service time. It is taking high DB time. It is taking high DB CPU's time. Now, what is your conclusion on this one? Every value is being increased. So I'm seeing high response time, high service time. So I'm seeing high DB time. So can you tell me what is your decision now? Do you increase some node or do you increase some additional server or do you recommend something to your customer? What is your recommendation being a performance engineer? So it can be anything. You need to come up with your you need to come up with your thoughts actually. What is that you can recommend?
You need to we can check these basic resources that we just mentioned, like
Okay.
CPU and network.
You are seeing some high values. Let's say that you are seeing some high values. Memory wise,
Okay.
CPU wise. CPU you are seeing some 75 to 80% or 70 to 75% continuously. So let's say I recommended to add another node or another cluster or another additional server. I am asking them to scale. I'm saying that whatever the server that I'm having right away, I don't think so that is capable of serving all the user needs. So can you please add another Oracle server to the existing infrastructure? So he said yes, and the server has been added. Now I still see the same issues. What is that you can do now?
Anything like DB upgrade?
DB upgrade. So when we say DB upgrade, what is that we actually upgrade in the DB?
Like latest version.
Okay. That is one idea, right? Right. Like you can upgrade it to one latest version. Yeah.
Yeah, when we, even after adding additional instances or scalability, if the scalability is not improving, then we need to take a look on the queries that are getting executed or stored procedures that are running.
Right.
That way we can tune them and bring it under control.
First point is the versions. Okay. You need to upgrade the versions. The second point is you need to have the same versions on both. On if you have two Oracle database servers, you need to have the same kind of configuration, same kind of settings, and same kind of versioning on both the servers. The second point is you need to identify all the long running queries, high load SQL statements. The third one is you need to look at the execution plan, schema design, and DB configuration issues, DB configurations, and you need to look at all the stored procedures which are taking very high time. And every time you see some high values in DB CPU, DB time, or high response times, or very high load times for many of the SQL queries, increasing another server will increase the throughput, but it will not improve the performance. Every time suggesting the customer to add another instance, another node, or another server will not improve the performance at all. I guarantee you to 95% that existing database to the adding another database to the existing infrastructure will not improve the performance. Instead, it will increase the throughput. Okay? And again, the response times will increase. If the throughput is increasing, if you see high throughput from both the servers, obviously you see high response times, right? Now the question is how the SQL query is processed. Anyone knows how the SQL query? Wait a minute. No idea? I'll show you that snapshot. Are you able to see this snap?
Yeah.
Yes, sir.
So when a user is trying to some SQL query, it first goes to parser. Okay? So parser basically, I'll tell you what is parser now. Parser will perform two different functions. Okay, one is syntax analysis and the second is semantic analysis. In syntax analysis, what it will do is the parser will check if the SQL statement is having the correct syntax or not. Okay? If you don't have the correct syntax, it will throw you an exception, and that particular query will not get executed. Okay? That is called syntax analysis. I'm sorry. The second one is called semantic analysis. It will perform two functions. You have to remember this point. Parser. The first one is syntax analysis. This basically will check the SQL statement for correct syntax. And when I talk about semantic analysis, it checks that the current database objects and object attributes in the SQL query are correct. Okay. If any of the object attributes or if any of the current database objects are not correct in the SQL query that is being executed, the query will not get executed. And again, there are chances of throwing an exception or the SQL query will not get executed. Understood? So I'll send you this PPT. This is a SQL PPT. This is one thing that will happen. Now, the SQL query after parsing, after performing two functions, syntax analysis and semantic analysis, checking the syntax and checking the object attributes are correct. This was taken care by the parser, and now it goes to the optimizer mode. Basically, this is an inbuilt function of the Oracle. What it will do is the optimizer is the heart of any of the SQL processing engine. Okay, for all the SQL queries, all the SQL queries will be taken care by optimizer. The Oracle server basically provides two different types of optimizations. One is RBO and one is CBO. RBO, I think from after 10G, RBO optimizer is no longer supported. From the recent versions, you only have CBO, which is a cost-based optimizer. Yeah. So what it basically do is it will internally try to optimize the query from the SQL processing engine directly. Okay, the optimizer will take care of the query and it will internally to 70 to 80% it will try to optimize the efficiency of the query, and it will ensure that the query is performing as expected without any performance issues. But obviously you tend to see when you have high user rate with high user concurrency, you will see lot of user I mean database slowness issues, right? You obviously see it, and you can identify all of them only by AWR, ADDM, and ASH with the help of TBA. But from the optimizer side, what it can do for you is, to the maximum, it can optimize your query and it can eliminate some kind of performance issues when you consider that particular query. Okay? Then from the customize, from any of the optimizer, it goes to row source generator. Okay? So what basically this row source generator will do is, it will check the execution plan of, I'll tell you in simple words. Row source generation, if you search in Google or in any of the learning blog, you'll have some 5 to 6 points. But from the performance side, the main important that we need to understand from the row source generator is, it will check the execution plan of that SQL statement, and it will check all the row sources that are structured from right from the line 1 till the last line, and it will check from the optimizer, and it will verify all the execution plan of that SQL statement. Okay, whatever the set of steps that you have in the execution plan for that particular SQL statement, it checks all of them. That is what a row source generator will do. You understood? From the row source generator, then it will go to SQL execution. This is where the combination of steps is nothing but execution plan are required to execute a statement. And again, it is called execution plan. Okay. And this execution plan will include, there is something called access method for each table. So that the statement can access different tables for ordering or joining the tables, or to access the data from multiple tables, you need some access method. For every execution plan, there is something called access method for every SQL statement, which will help that SQL statement to access all the data from different tables, or it can order all the tables, or it can join the data from any of the tables inside one single database. This is the basic SQL, how the SQL will work. Okay, so this is one thing that uh, yeah. So you understood till here?
Yeah.
Because to optimize the SQL query, you need to understand the limitations of the query. You need to understand how a SQL query will work in the SQL processing engine in Oracle SQL Server. When a SQL query, when a user is trying to execute something, what is the first step that happens to a SQL query? It goes to the parser, right? The SQL query is not executed. The SQL query is getting, you are seeing continuous errors on SQL queries. How do you troubleshoot that SQL query? It must be having some incorrect syntax. The first thing. The second reason, it can be having some wrong object attributes. The third thing, you need to check for all the database objects that they are existing or not. Whatever the objects that you have highlighted in the query with a PL SQL function in a SQL statement that are already there or not is what you need to verify. The first thing is the SQL query has to work. It has to execute as expected. It has to give the desired output. The last point is when it is functionally stable, when it is working, when it is throwing you the result, what user is expecting, then you are worried about the performance of that particular SQL statement, right? So when it goes to the parser, when it verifies everything there, it comes to the optimizer. Optimizer to the maximum, the inbuilt functionality of the optimizer for the SQL processing engine is to optimize the query internally that comes with Oracle by default. So let's assume that it will do its best to improve the performance to eliminate the degradation of that query. Then it goes to row source generator by using cost-based optimizer. We will not go in depth what is rule-based optimizer or what is cost-based optimizer. It goes to row source generator. What row source generator will do is it will check for all the execution plan of that particular query. It will check for all the sequence of the steps of that particular query, and then accordingly it will try to execute the SQL query, right? But again, every execution plan will have a combination of steps. They can also be called as instructions of a SQL query on how it has to be executed. Okay, that is point number one. Point number two is every execution plan, for every SQL query, there is an execution plan, how it has to be executed. And this execution plan will include something called access method. What this access method will do, this access method for every execution plan of every SQL query will help to access each table. Okay, if it is accessing so much of data from multiple tables of, or if this execution plan wants to, by using this access method for each table, if it wants to access the different data that we have in different tables, or if you want to join the data, if you want to order the data, you need an access method. This is how basically the SQL query will work. And again, when you see some high service time or high load time of a particular SQL query, then As we discussed, we use the segment advisor, SQL tuning advisor. Before you tune or before you optimize any of the SQL query, you go back and you try to analyze the impact of the execution plan again. Changing any of the SQL query is showing some impact on the execution plan or not is what you need to verify when you are using any of the tuning advisors. Okay, let me explain you very clearly in uh, the database that I have installed. Okay, when I show it to you, I'll explain you that. Need not worry. So, because the confidence what I have from the Oracle AWR report is uh, the one even who is evaluating you from any of the entry evaluations, right? He doesn't even know what exactly you have in uh, AWR. Even if I even doesn't matter, even if I teach to many of the students, if someone is asking me what is this global cache blocks received, I'll fail my interview, right? So that is the main important point here. It is very difficult to understand all of the areas in the AWS. From our side, we are worried about the CPUs, DB time, and you need to look at the top five timed foreground events. And there is something called instance efficiency percentages. AWR. Yeah. So these are all different things that you need to look at the hard parses and soft parses rollback. And I have written some notes here, some values. Uh, Check if the numbers are consistent, or you need to pay most attention to the physical reads, physical writes, and the transaction ratio. What there are no specific fixed values, but if you look at this particular value, right, high hard parse ratios greater than 2 to 3% indicate probable bind variable issues or maybe versioning problems. This is a simple thing. If you see high hard parse ratio, right? If it is more than 2 to 3%, like someone told me just now, some 10 minutes back, you need to there must be some worsting problems, and you need to go back and you have to upgrade the Oracle SGA architecture, or you need to upgrade some components with respect to the versioning changes, and that can reduce the high hard parses value. Okay, so mostly uh, yeah, and if you look at the reader sizes, right, the main sources of reader are if your application is having lot of insertions, updations, and deletions, right, for all the you will obviously have very high reader size, because every application will have inserting, updating, and deleting, especially the BFS applications. If you take, or if you take other applications, right, you will have so much of continuous accessing to this thing, uh, application. So they keeps continuously doing all the insertion, deletion, and updation. When any application is having too much of, not too much, even a minimum of insertion, updation, and deletion of the data, you will see the high reader size. So if the reader size is small, then it means that many of the transactions are failing. It is a very big bottleneck. Reader size is a very important. Reader size is very important. So, and if you look at something called the instance efficiency percentage, I have written here what does high reader mean. I'll send you this document. Yeah. So If you look at this, this is one of the another important section after the load profile. The immediate section that you, the next immediate section that you see is instance efficiency percentage. Okay? I will tell you one straight point for this section. Buffer no wait, buffer hit percentage, library hit percentage, execute to pass percentage, parse CPU to parse elapsed. Okay, all the metrics that you are seeing, the overall target of this section should be 100%. Okay, the goal of all the in instance nearing to 100%. If you look at all these values, mostly all of them are 99, right? Except execute to parse percentage and parse CPU to parse. There is one value called percentage non-parse CPU. This is the most important metric from the performance side you need to look at in this section. Percentage non-parse CPU is the last one. If you 99.46 is the value. So in this instance, efficiency percentages, in these statistics, you need to look at percentage non-parse CPU. If this value is nearing to 100%, now currently we have 99.46. This means that all the CPU resources are used into the operations other than parsing, which is a very good sign of database health. You understood this point? If no percentage, you can write in a notes. How do you define your database health is good or not? How do you know? How do you get to know whether your database health is good or not? You go back to instant efficiency percentages. You go to something called percentage non-parse CPU value. If it is nearing to 100%, that all the CPU resources or all the CPUs, 64 CPUs that I have in my Oracle server are using or used into all operations other than parsing, then it is a direct indication for which is good for database health. Okay, and we will talk about top 5 foreground events and time model statistics tomorrow. Okay, so we'll stop here because there are 3 different sections: SQL queries, time model statistics, and top 5 timed foreground events. Is 3 different sections. Basically, this instance efficiency percentage, one last point I would like to add, is nothing but how much time the CPUs are spending in parsing the SQL statements is what you will understand from the instance efficiency percentage. If you see high amount of CPU there, you need to investigate that why CPU is spending so much time in instance efficiency to execute or to spend so much of time in parsing all the SQL statements. And here you need not tune any of the instances. So what we will do is we will talk about parsing tomorrow in detail. Okay, I'll tell you what the parsing will do in a SQL statement, right? Now there are hard parses and soft parses. I'll tell you one bottleneck from low hard parses and high soft parses and how to fix them. Okay, so the reason for very, we are going very slow with this AWR is because AWR is very important concept in performance engineering. I can close this AWR report in 1 or 2 sessions, but that is not my objective. We are going to talk about all the different sections. After explaining all these sections, I will explain you some 5 to 6 bottlenecks and what is the fix for that. Because when you go for any of the entry evaluations or when you attend any of the interviews, No one will give you an Oracle database server, and they'll not ask you to generate an AWR report and identify the issues. The only common question every performance engineer from 1 year experience to 15-year experience, what they will be asked is, have you ever involved in database tuning? What is your approach? How did you find the performance issues? What did you identify from AWR report? What is the significance of different sections that we have? If we are talking about instance efficiency percentages, what are all the metrics that you will see in the instance efficiency percentages? What does percentage non CPU mean? So these are all the things that you need to prepare. Prepare your notes. Keep your notes handy. Like if you, if you want to explain any of, there is another important question like, what are all the key bottlenecks that you have identified from AWR, and I'm not talking about the recommendations here. What is the fix that has been given to improve the performance of that particular issue? I have some 6 to 10 bottlenecks for the Oracle database for database replication testing. If you are preparing all these 5 to 6 bottlenecks, you can crack any interview from the database tuning side. Okay. After completion of the AWR class, I will share all this documentation with you. Go through this documentation. I know it is very hard to read all the documents. That is why I keep asking everyone to prepare their own notes. You need not by heart, or you need not read everything that you have or that is there on the internet from the n number of blogs. Prepare your own notes. Keep your answers handy. Highlight your main points. You need to have some real-time scenarios, the bottlenecks identified, and the fix that has been given. That is what is the final motto. All right. So we'll meet tomorrow at the same time, and we'll finish the AWR tomorrow. All right. Any questions you guys have?
Oh, okay. Thank you.
Any question? All good?
Yeah, thanks.
All right. Thank you so much.